All right, so let's move on to the third example, which our favorite ones are Cobb-Douglas. And so if you remember, these are the utility functions, so these are the preferences that can be represented by the utility functions, x1 to the a, x2 to the 1 minus a, where a is the fraction of your income that you're spending on good 1, and 1 minus a is the fraction of your income that you're spending on good 2. And remember, we can always take a monotonic transformation if they have any kind of Cobb-Douglas preferences to make it so we have this kind of form of it. And we kind of discussed that the demand function for good 1, we have preferences like this, is a times m over p1. So we're spending a constant fraction of our income on good 1. And so if we held prices constant and doubled our income, we're going to double the amount of good 1 that we demand. So for constant prices, doubling income will double the demand or the optimal choice for good 1. And then, I mean, for each of the goods, right? I mean, x2, we're spending 1 minus a times m over p2, where we're spending that 1 minus a, this constant fraction. So if we kept p2 constant and we doubled m, x2 is gonna double, right? Okay, so we can, we can do what we usually do with the demand function. We can rearrange it. So we can write it out again. X1 equals a times m over p1. We can rearrange it so m is now a function of x1. And if we do that, we just multiply by the inverse, and we're going to get x1 times p1 over a. And this will be useful when we kind of draw that Engel curve that we've been drawing before, right? Making sure that this is, our y variable, this is our x, this is going to be the slope of the Engel curve. But let's erase this, we'll draw out our income offer curve, and then we'll draw out this Engel curve showing the relationship between income and the amount of, the optimal choice of good 1 here. Correctly this time. Okay, so x2, the amount of good 2, x1, the amount of good 1, and we're going to draw the optimal choices and the income offer curve here. Over here, we're going to draw this relationship between income and the amount of good 1. All right, so what's happening here is we're just varying income. So these parallel shifts in. And what's happening with these Cobb-Douglas, and it's going to, I'm going to end up drawing this line, the income offer curve, before these other curves, is this should be this straight line again out of the origin, where that's connecting all these different optimal choices. So it's a straight line out of the origin, and this is the income offer. I just drew this straight line before drawing those indifference curves of showing the optimal amount, just because I wanted it to be a straight line out of it. And if I draw a freehand, it has the tendency to be squiggly rather than this straight line. And so we're going to draw over here is the Engel curve. And as we just said, remember m equals x1 times p1 over a. So again, you think of it as equation of a line, we have the straight line going out of the origin, which is the Engel curve. And you might think that this is always the case because every line we've drawn has been a straight line out of the origin, but that's not going to be the case. We're going to talk about that in a few minutes. But as a slope of P1 over A. And so the slope of the Engel curve for good 2 would be, P2 over 1 minus A, for instance. All right, so this is what the income offer and the Engel curve look like for Cobb-Douglas preferences. The same kind of shape of these angle curves, these linear kind of rays from the origin with the same, constant slope. I mean, the slopes differ depending on which preference you looked at, but the slopes were constant within each kinds of preference. But that doesn't always need to be the case. And so those are examples of what we're going to call homothetic preferences. So in general, I should capitalize Engel. Engel curves need not be straight lines from the origin. Need not be straight lines from the origin. The last few examples we've seen, they have been. It doesn't have to be the case. If, in general, if the demand increases by a greater proportion than income, by a greater proportion than income, we're going to call these goods luxuries. It's a luxury good. If demand for the good decreases or increases again by a lesser proportion than income, we're going to call that a necessity. So what I mean by that is if your income went up by 100% and the amount of good one you demand goes up by 150%, it's a luxury good. Whereas if for necessity, if your income goes up by 100%, your demand for that good will go up by less than 100%, for instance. And so kind of the dividing line is if your demand goes up at the same proportion as income. And that's the kind of goods we've been looking at the entire time. All these preferences are examples of homothetic preferences where the demand is increased by the same proportion as income. So if neither is true, so increase in demand is the same proportion as the increase in income. Hopefully that makes sense what I'm trying to say here. This is the dividing line, and this is what we've been looking at. These kind of preferences are the kind of preferences we have seen so far in both the perfect substitutes, perfect complements, as well as the Cobb-Douglas have had this property, whereas the quantity demand goes up by the same proportion as income. That's probably easiest to see with the Cobb-Douglas, where we're spending a constant fraction, right? And so essentially, I mean, what these indifference curves or what these preferences kind of look like. So if we had some, if we multiplied the amount of each good by some constant C, for C greater than for 0, this would be equal to C times the utility of x1, x2. So this is kind of what homothetic preferences in general kind of look like, those utility functions look like. But let's kind of take a closer look, or maybe kind of define maybe this in a different way, so you hopefully can pick up what I'm trying to say. Homothetic preferences. Then their preferences depend on just the ratio of goods. So it doesn't depend on income or scale. So by that I mean if x1, x2 is preferred to y1, y2, and preferences are homothetic, then that must be then 2 times the amount of good 1 and 2 times the amount of good 2 in this first bundle must be preferred to 2 times the same amount of the amount of good 1 and good 2 in the second bundle, in bundle Y. And in general, T times x1, we're using C before we talked about utility function, but T is just some constant, is preferred to T times the amount of good 1 and good in bundle Y, and the amount of, and T times the amount of good 2 in bundle Y. For all T greater than 0. And so if you have homothetic preferences, this is true. So your preferences are just about the ratio of the amount of goods. Then homothetic. So what I mean by this is if income is scaled by some amount, again, we can call this T, this amount can be called T, it's not quite the same as this T. The demanded bundle is scaled by the same amount. So that's what homothetic preferences mean. And we saw that exactly with the Cobb-Douglas. It was really easy to see with the Cobb-Douglas, right? Where we're spending a constant fraction of our income on each of the goods. Well, that just means if we double our income, we're going to double the amount of each good that we have, right? So that was very easy. We could do the same thing for the other preferences we've seen. You're going to see this is consistent, or this is true for all these preferences that we've seen so far when we've been drawing their Engel curves. And so what's happening here is that's why we have these kind of straight lines out of the origin for these Engel curves, is because all these preferences we've looked at so far this chapter are homothetic preferences. But let's look at quasi-linear preferences, which have a little bit different of a shape.